Hey everyone and welcome back to the channel. Today, we're diving deep into one of the most common and often misunderstood check engine light codes out there. P0420, zero catalyst, system efficiency below threshold. If you've seen this code pop up, don't panic and rush to buy a new catalytic converter just yet. There's a lot more to this code than meets the eye, and we're going to break it all down. So, what exactly does P0420 mean? Your car's computer, the ECU, is constantly monitoring the exhaust gases. It uses two oxygen sensors, one before the catalytic converter, called the upstream or front O, two sensors, and one after it, the downstream, or rear O, two sensor. The upstream sensor's reading should fluctuate rapidly as the engine adjusts the air-fuel mixture. The catalytic converter's job is to clean up the exhaust, so the downstream sensor's reading should be much more stable and steady. If the computer sees the downstream sensor starting to mimic the rapid fluctuations of the upstream sensor, it concludes that the converter isn't doing its job efficiently. That's when it triggers the P0420 code and turns on your check engine light. Now, here's the crucial part that many people miss. A P0420 code doesn't automatically mean your catalytic converter is bad. In fact, a failing converter is often a symptom of another problem, not the root cause. Think of it like this. The converter is the victim, not the culprit. Something else is causing it to fail. If you just replace the converter without finding that underlying issue, you'll likely be back with the same P0420 code in a few months, and you'll be out a lot of money. So, what are these other potential causes? One of the biggest culprits, especially in European cars, is an incorrect air-fuel mixture. If your engine is running too rich, meaning too much fuel and not enough air, that unburnt fuel gets dumped into the exhaust system. When this raw fuel hits the extremely hot catalytic converter, it essentially incinerates inside the cat, causing it to overheat and melt the precious metals within the catalyst brick. This is what destroys its efficiency. Similarly, a lean condition, too much air and not enough fuel, can also cause problems by raising combustion temperatures, which in turn can lead to higher NOx emissions and damage the converter over time. Things like ignition misfires are also a huge red flag. A misfiring cylinder is sending a potent mix of unburned air and fuel directly into the exhaust, which is a death sentence for a catalytic converter. So, how do we properly diagnose a P0420? The first step is to forget about the converter for a moment and look at the bigger picture. We need to become detectives. Your best tool for this is a good scan tool that can display live data. Specifically the graphs for your oxygen sensors. Connect your scanner and get the engine up to operating temperature. Pull up the graphs for your upstream O2 sensor, sometimes called Bank 1 Sensor Runo, and your downstream O2 sensor, Bank 1 Sensor 2. The upstream sensor should show a wave-like pattern, cycling quickly between about 0.1 volts and 0.9 volts. This is normal. Now, look at the downstream sensor. A healthy, working converter will produce a much flatter, steadier line, typically holding above 0.5 or 0.6 volts. If you see your downstream sensor S graph looking just as choppy and active as the upstream sensor S graph, it confirms the computer's suspicion. The catalyst isn't storing and releasing oxygen properly. But this is where the real diagnosis begins. Before you condemn the cat, you must check for other issues. First and foremost, check for exhaust leaks. A leak anywhere between the two oxygen sensors, or even slightly before the upstream sensor, can suck in fresh air. This extra oxygen will fool the sensors and can absolutely trigger a false P0420 code. Use a smoke machine if you have one, or carefully inspect the exhaust manifold, gaskets, and flex pipe for any signs of soot or cracks. A small leak can cause a big headache. Next, dive back into your scan tool data and look at your short-term and long-term fuel trims. These numbers tell you what the computer is doing to maintain the proper air-fuel ratio. If you see high positive numbers, say over 10%, it means the computer is adding a lot of fuel because it thinks the engine is running lean. This could be caused by a vacuum leak, a weak fuel pump, or a dirty mass airflow sensor. Conversely, if you see high negative numbers, It means the computer is pulling fuel out because it thinks the engine is running rich. This might point to a leaking fuel injector, a faulty fuel pressure regulator, or a problem with the purge valve. Any significant fuel trim deviation needs to be investigated and fixed before you even think about the catalytic converter. Also, check for any other pending or stored trouble codes. Codes for misfires, fuel mixture, or other sensors are massive clues. Always address these other codes first. If you have a misfire code, for example, you need to fix the cause of the misfire be it a spark plug, ignition coil, or injector before you do anything else. Only after you've confirmed that there are no exhaust leaks, your fuel trims are in check, there are no misfires, and all other engine systems are working correctly, can you then confidently condemn the catalytic converter? At that point, and only at that point, is it time to replace it. By fixing the root cause first, you ensure your new, expensive converter will have a long and happy life. So remember the key takeaway. P0420 is a code about catalyst efficiency, but the problem often starts somewhere else. Be a good mechanic, do your diagnostic homework, and fix the source of the issue. You'll save yourself time, money, and frustration. Thanks so much for watching. If you found this video helpful, give it a thumbs up, and consider subscribing for more in-depth car repair guides. Drop any questions you have in the comments below, and we'll see you in the next one.